this second part, he will continue to focus on adaptations needed to remain competitive and to produce high-quality feed in times of raw material scarcity and, of course, high energy prices. Remaining profitable without losing quality is a key topic. The questions are again open via the Mentimeter system, and of course I will shortly open it up again a few seconds for anybody that has lost the connection with the Mentimeter system. Just briefly scan the QR code right now, then you are sliding into the system. A very easy way to raise the questions for the speakers that are here. There's still two to come, and of course all the panelists, and we have some questions for you, but if you have questions for us, please feel free to raise them. The questions are of course for Ernst. Ernst, we're listening to you.
So welcome back to part 2, where we will continue with pelleting and cooling. Just come to the first slide. Compacting as a refining process for the mixed mash leaves not much space to optimize process technology as a short-term solution. Much more, we should make sure or ensure that apply the few parameters available in a most efficient way. Influencing factors like physical and chemical properties and mash preparation, which includes also the grinding section in group raw material and mash, as you can see on the top, contributes to approximately 55 to 65% on the behavior of pelleting, which determines finally the pellet quality and the power consumption of the pellet mill. Exactly the top two, these physical and chemical properties, are currently the troublemakers, because we are obliged to utilize what's available and payable in the market. Most parameters like the circumferential speeds of the die and roll diameters and others in group machine and pellet mill on the bottom must be selected as early as when a pellet mill is purchased. So what's left finally, it's basically group process and process control, means steam conditioning, throughput regulation and moisture content or moisture control. Why steam conditioning? The stability of a pellet depends very much on number and size of solid material bridges and adhesive forces at the contact point of two particles, as you can see it in the slide in brown color. By steam conditioning, we are introducing energy, heat and moisture. What softens the solid particles means generating more and larger solid material bridges, contributing to higher stability. Liquid bridges, or so-called capillary forces, are formed by natural moisture natural moisture in the mash and the added steam, which condensates then, and contributing further to the stability of the pellet. In general, we can say higher the conditioning temperature, better the quality, and lower the energy consumption. But everything has a limit. So, for instance, due to maximum moisture content and destruction of nutrients, steam conditioning is limited somewhere in the neighborhood of 80 to 85 degrees. All just mentioned above only happens by providing slightly superheated steam, means steam temperature must be at least 5 to 10 degrees above saturated steam temperature. What does it mean in the diagram? Steam installation and steam quality is the main issue in many plants for low conditioning temperatures, too high product moistures, frequent pellet mill chokes, weak quality pellets, and elevated energy consumption. So let's take a closer look at the function of some important steam fittings. Steam supplied from the boiler at 7 to 9 bars usually arrives as wet steam at the plant. So it needs to be dried and transferred into superheated steam. This process takes place at the mechanical water separator, you can see it in yellow color, in the first stage, and by the PRV, the pressure reducing valve, as a second and final stage. The following thermometer and the pressure gauge at the top are the most important elements in the total installation, will inform us about the steam quality. Obviously, if one or the other is missing, which is quite often the place. No information about steam quality is available, and we are walking in the dark and guess why the pellet mill chokes. Looking at the die configuration, or rather the dwell time in the die hole, this is one of the only available parameters from the pellet mill side to optimize the pellet quality. It can be influenced by the number of holes in the die. This would require more holes, a wider die or a bigger die, or by other words, a bigger pellet mill. Another possibility is to increase the volume of the die hole, requires a thicker die, what automatically raises the resistance in the die hole, means an increase in energy consumption and possibly a lower conditioning temperature. Or, as a real-time solution, reduction in throughput. This is, of course, not a desirable solution, but often no other choice available, because neither a bigger pellet mill nor a thicker die at this moment is available. As a rule of thumb, we can say the longer the dwell time, the better the pellet quality. However, above 5 to 6 seconds of dwell time, improvements tend to stagnate. Associated with a moderate investment, applications of automatic roll gap adjustment would also be another possibility to improve qualities of finished products. Some essential points to consider in optimizing the pelleting process in general. Die hole diameter and the length of the hole determines the compression ratio of the die, and there we find common and economical ratios in the range of 1 to 10 to 1 to 15. Dies with parallel hole arrangements, as you can see on the top of the print, perform better than staggered hole patterns. They will lower the energy requirement, they are easier to start up, and the service wear will be more uniform. Die damages could arrive, or excessive wears lead to increasing energy consumption or a decrease in throughput. In this case, refurbishments or replacements of the die will solve the problem. For a high reliability, press rolls supposed to show a large diameter and a grippy surface. This kind of press rolls are going to reduce the roll slippage or the relative movement in between the die and the roll, and consequently consuming less energy. Poor product distribution results in an uneven wear, irregular pellet quality, and a loss in capacity. Therefore, deflectors need to be regularly adjusted, or if they're worn out, they need to be replaced. Finally, also the automated process control contributes to energy saving. Set values like conditioning temperature and throughput rates usually are on a higher level and are faster reached than with manual control. Cooling and drying for safe and trouble-free storage conditions, optimized by adjusting retention time and the air volume, which is more often required with frequent changes in product property, but also of different pellet diameter. In terms of retention time, the question is who is going to move the level probe to adjust the product layer in the cooler? Question mark. In terms of air volume, who is going to position the butterfly, usually on the 8th or 10th floor, to adjust the exhaust air system? Also, there is a question mark. Much more reliable and lower in energy consumption is an online adjustment by locating the cooler on load cells, or control the product layer by radar sensors, and operate the fan motor with a variable speed drive. To achieve the target value in temperature and moisture, as indicated on the slide, the system will select automatically always as a first parameter, the more economical parameter. So, for instance, in case of too high of product temperature, we are going to increase the retention time, which is cost-free, and in case of too high moisture in the product, then we are going to decrease the air volume in order to save energy. So always the more economical one first. So finally, coming to the moisture management, online control, improving quality and efficiency by compensating moisture fluctuations in the raw material. The target, of course, is to have a constant moisture content at the pelleting process, somewhere in the neighborhood of 15 to 17%. Depends a bit on the region. This will provide good and constant pellet quality. It will also lower the energy consumption. That means there are savings in energy, and will give higher availability of the pellet mill because we are having less chokes of the pellet mill. Last but not least, there also will be less product spoilage and less mold formation of the product in the storage bins, in the plant, or also at the farm. So how does it work? We are going to measure the moisture content and the temperature in the mixer and compare it, mixer or in the surge hopper in front of the pellet mill. Two opportunities possible, and are going to compare it with the set value of the conditioning temperature, and then we calculate the quantity of water to be added in a combination with mold inhibitors or surfactants. This is an option to obtain the required moisture content at the pellet mill. The same will be done at the cooler to control the moisture content and the temperature of the finished product by controlling online, as I mentioned before, the retention time in the cooler and the air volume, both online, by locating the cooler on load cells and driving the fan motor by a variable speed motor. So I was talking, variable speed drives have been mentioned many times during the last hour, so it's about time to show you how it works and what the benefits are. On the example of a fan controlling the air volume, once with a damper and once with a variable speed drive. So you can see on the graph on the top, it will be with the control with the damper, and the lower graph, it's the control with variable speed drive. Concentrate a little bit on the blue points. I cannot point it, but if you look at it, then you will be able to follow. Looking at the first one with the damper, if you reduce the air volume from 100% on the horizontal axis down to 80%, you will see there is a blue point up there which shows that we are going to save about 10% of energy from 100 to 80. If you do the same thing with a variable speed drive, then you will see on 80% air volume, the blue point, that means the energy consumption drops down to about 55%. So there is a delta T in energy of about 35%. That means with a frequency converter, we will have savings up to 40% in this case, without any efficiency losses. Another advantage of the frequency converter will be if you change the fan speed, you're also going to change the air volume in a linear way. This will not happen if you close the butterfly, for instance, by 20%. There is no guarantee that 20% less air volume passing through the duct, or more or less 20%. Another point to save energy, potential for energy improvements by adapting the motor efficiency levels. Since 2014, the 4 efficiency levels are the new standards, starting with IE1 to IE4, from low standards to super premium efficiency. Since 2017, E3 levels for new driven motors are compulsory. IE2 levels for new variable speed drives motor are still accepted, but also there better to have IE3 or 4. So in grinding and pelleting sections and other sections, there we have still large motors, and many of them are quite old motors with efficiency classes or levels from IE1 or even below, and not even indicating anything about the efficiency, and a replacement with EI3 or EI4 motor level will give you savings in energy, but also stability under partial load range. For instance, if you look at the graph, you will see smaller motors will have bigger energy savings, but only in percent, not in kilowatts. For instance, if you take a 15 kilowatt motor as an example, shown in the graph, then you will have savings of about 8%, which corresponds to approximately 1.2 kilowatt. If you move over to a 200 kilowatt motor, then you will see the savings are only about 4%, but in kilowatts, it will be, instead of 1.2, it will be 8 kilowatts. Then, coming to my last slide, I mentioned it already before, I promised to come back to compressed air as an underestimated cost driver. Why is it so? First, some basic recommendations on compressed air systems. Keep the pressure low as possible. Reduction of 1 bar results in an energy savings of about 5 to 6%. So pressures around 4 to 5 bars are normally sufficient. Applying a variable speed drive, as just mentioned before, gives you, as we have seen, savings in between 20 to 40%, a possibility. And also there is a possibility to recover energy, for instance, heating rooms or to heat water. Not very common, but in some areas possible. The most important part, and this is the reason why it's an underestimated cost driver, find leakages and eliminate them. Small leakages are also cost effective. And in this context, I advise you to walk once through your plant on a Sunday morning when the plant is stopped, instead to going to church, and you will hear in each floor in several points, psst, psst, psst. That means leakages everywhere. And if you look at the example in the graph of a 1 millimeter hole, what the savings are, then it makes sense to find these leaks and eliminate them. Proper adjustment of the plant equipment who requires compressed air. It's also another issue. For instance, aspiration system, back filters, the length of the pulse intervals and the length of the pulse length could have a tremendous impact on the compressed air consumption. Finally, we can say preventive maintenance, it's another contribution to save production costs. Thank you.
Thank you so much, Ernst, for your presentation. A lot of questions have been raised already. Some a little bit generic, some a little bit specific. So we badly need you here at the table. And at the table, we still are here with Paul and with Geke. So I will, of course, also enlarge the discussion. A couple of questions, and bear with me, Ernst. I mean, there are a lot. So if you give the short answer, I will do a lot of questions, and then we will write it. Okay. There we go.
If I'm able to answer.
I don't know. Some are very specific. What is the main cause for pellets to crumble after manufacturing?
What is the main cause?
For pellets to crumble after manufacturing.
This is very much animal related. Usually crumbles are done for broilers, for instance, for piglets, because the pellet is just too big for the animal. But it is cheaper than to produce a 2 millimeter pellet and give it as a 2 millimeter pellet to the animal. So we are going to produce a larger pellet and then crumble it again. This is a cheaper solution.
That's a cheaper solution. Yeah. It's cost effective. Paul?
Yes, I'm not sure whether the question was about what is the essence of crumbling
or why does it crumble?
Why does it crumble?
Yes,
because when it crumbles, it means that the quality of the feed of the process is not decent.
And what is that then? Heat or moist or...
Conditioning. In most cases, it's conditioning. And my experience from the plants I have seen around the world, the biggest problem, it's always the installation of steam and the steam quality. Because one of these two elements, thermometer or pressure gauge, is missing or broken.
Okay.
They're always indicating 6 bars because the needle is broken.
Okay. And that is actually a practical tip, like Sunday morning, have a walk.
Yes.
And could you do the sound again? What do you hear?
No.
Yeah, and that's leakage.
Yes.
Right.
But it's not for steam.
So in essence, when you're missing the required amount of steam, you won't get the compaction that Ernst was talking about.
And therefore it will crumble after manufacturing.
Yes. Too soon.
Yes. Too soon.
Yeah.
Yes.
Even
if you don't want it.
Content, too low in conditioning.
Okay. Could you give some practical tips on how to adjust the cooler in hot climates?
In hot climates.
Yes, I mean, if we are in, for instance, Asia, hot climate, or Middle East, how could we tips and maybe tops what to do or what not to do to adjust the
The
cooler?
hot climate itself, it's not a problem.
Okay.
Because we said we want to cool it down to 5 to 10 degrees above ambient. And in hot areas, we rather go closer to 5 than to 10 due to avoid mold formation. The difficulties will be hot climates and high humidity.
The combination.
The combination.
So if it's a dry hot climate, that should be no problem.
Less of a problem.
But a high humidity combined with a hot...
Could be a problem.
And why is that a problem?
Because you are not able to cool it down to the right, or to dry it down to the right moisture content. You are going to add again moisture with the incoming air.
Yes.
And I have seen plants in Far East countries where they have a big sign on the cooler what the humidity of the air is. And once they exceed a certain value, they just stop the plant for a certain time. Until the evening or in the night when the humidity comes down again.
Paul? You see that as well in when we have more time, then Ernst could present as well the storage impact on absorption terms. So when you have Mother Nature dictates that when you have high relative humidity and you're storing in high relative humidity, measuring AW value of activity of free water, and the surrounding temperature is low relative humidity, then it means that it will find itself in equilibrium, so the moisture will disappear. And that is very often a request that you will get, okay, what can you do to stop this? And it's a law of nature. So you only can delay it in a way, but you cannot overcome it.
Okay.
There is always the question, should we apply conditioned air?
Yes.
And the question is, yes, but you have to pay for.
And
because this is a huge volume of air which you have to condition. Just a short calculation.
Yes.
Plant capacity of 20 tons.
Yes.
It's a small plant, 20 tons.
Yes.
With a specific air volume consumption of 20 meter cubes per minute per ton per hour. Makes 20 times 20. Makes 400 meter cubes per minute, which you have to air condition.
Wow.
This is just for a small plant.
Yes.
And just for one
sometimes it's not doable.
It's just too expensive.
Expensive to do so, yes. Let us go to some other questions that have been raised, very specific sometimes. Dwell time, die length, will it not reduce the expansion?
No.
Okay. No. I have learned that the die is critical part of the pellet feed mill, though.
Yes, it's most critical one.
Yes, most critical one. Then a question, a very specific one. During shortage of raw material, we can use low-cost raw materials by balancing nutritional contents, like sugarcane molasses. What the question is what is the difference between sugarcane molasses and molasses beet?
Beet molasses, it's a little bit lower in viscosity.
In viscosity?
In viscosity. Cane sugar, it's a bit higher in viscosity. So the bricks are a bit higher than in beet molasses usually.
Okay.
What is your opinion when you have very viscous molasses that you would like to lower bricks? And what I see is that some feed millers are adding water then to the molasses to have a more liquid fluid substance.
The adding water process, or let's put it this way, diluting molasses with water, it's not just a process, take 2 cups and a little bit of molasses and water. It's a long process. It takes, as far as I remember, about 7 hours to dilute molasses with water. Yeah. So much more advisable in this case, instead of just adding somehow water, it's to heat the molasses up to about 40 degrees. And usually we say molasses not supposed to have a higher viscosity than 600 millipascal.
Okay. Yeah. Then another very specific question on how many percent, that really don't know if you know this by heart, but how many percent of the sugarcane molasses is recommended per ton of feed for chicken layer and cattle's dairy fattening?
Okay. I'm not a nutritionist, so I cannot give you the answer for the animal, but I can give you an answer for the process.
All right.
So for the process, you can go up to 5 to 6%.
Okay.
But always providing what kind of raw material you're going to utilize. If you utilize cheap raw material with poor pelleting properties, which is not going to absorb moisture, it will not absorb the molasses. And then you will have a problem.
Yes.
But technically, if you have the right, let's say, fiber which absorbs molasses quite
Yes.
easily, or humidity in general, then you can go up to 5 to 6%.
Okay. Thank you. Superheated steam gives off heat less readily than saturated steam and takes more energy. Is there any research been done about that?
Can you repeat? Sorry?
Of course, superheated steam gives up heat less readily than saturated steam and also takes more energy. Somebody states.
To produce.
Yes. Is there any research been done about that?
Not by myself.
No. Okay.
No, the problem to give maybe an answer. There are experts. They're saying we should utilize saturated steam or even wet steam, especially if you have dry raw materials. And then with wet steam, you're going to add, in the meantime, with the steam, you're going to add water. So you're going to raise the moisture content, but you do not know how much water you're going to add because it comes shockwise and uncontrolled. So we say slightly superheated steam, slightly above this line, 5 to 10 degrees, and then add the water with a water meter, with a flow meter, exactly what you want. Otherwise, you're not doing what you do not know what you do.
Okay.
Maybe it's good to
Yes, Paul?
to turn around the question and to say why is it important to utilize dry steam? It takes time. It's easy to create heat, but it takes time before the heat comes in the particle. So you can imagine when you have a difficulty by adding liquid to feed, then they say, like Ernst was mentioning, feed millers are just jeopardizing steam quality and just adding more liquid water in the conditioner. By doing so, you will not achieve your temperature target, and will also delay the moment that the steam which is there available will really penetrate the feed. And as a consequence, then later in the process, you will have an inferior pellet quality.
Thank you so much. Final specific question, and then I will broaden up in a generic way. What do you recommend the normal mixing time for pre-mixing? And then second, when the mixing starts, can you guide about time? Let us focus at the beginning of the question. What do you recommend as the normal mixing time for pre-mixing?
Are we talking about pelleting or
I think about pelleting, yes.
That's,
it doesn't say, but I'm assuming it as well.
I think it's dry mixing that they refer to, no?
Yes?
I guess.
So it goes back to the mixing plant.
I think so. It's
about
one of the
premix?
last questions, so it is...
In the feed mill or premix related?
What do you recommend as the normal mixing time for pre-mixing? And when the
For
mixing starts...
Pre-mixing.
I think it's dry mixing time.
Dry mixing time in the mixer.
Yeah.
If it's related to the mixer, then I'm just going to repeat what I said before. At least 2/3 of the mixing time supposed to be dry mixing.
At least.
At least.
Okay. And yesterday you also made me a very valid comment that when you are utilizing a pedal mixer or a ribbon mixer, it can make a substantial difference, no?
Yes, yes.
That's what can you elaborate what is the difference between pedal
For paddle mixers, or let's say I call it conventional mixers, long mixers where the length of the mixer is about 2-3 times the diameter, we say 2/3 of dry mixing time of the mixing time, 2/3 of the mixing time. And for modern mixers, paddle mixers, where the mixing time is much shorter, we say total mixing time before adding the liquids.
Yeah.
Yeah. And in this respect, it's really very important. You cannot just say it's 2 minutes or 3 minutes, or it is really, depending on the type of product, depending on the mixer itself. You always have to do this validation to really make sure that you have indeed the homogeneity that you are looking for, because there are so many factors influencing it that you have to do this validation testing. You cannot only calculate it.
Yeah. In this context, any mixer supplier supposed to be able to tell you what the mixing time of the mixer will be and how much time you need to premix.
I assume that the person that has raised the question can also refer locally to his local account manager, I assume, because otherwise. But thank you again for all the very specific
But I just want to add
responses.
to that. It's in the commissioning and in the testing, it's always important to do a test as well to verify that.
Okay.
So
Yeah.
it's so important.
We figured out that when it comes to sequencing in the right order, as you already discussed in the graph, that when you're adding oil and water for moisture management purposes or whatever, that it's vital first to apply the water solution in combination with the surfactant or mold inhibitor, and then the oil. Why? Because particles, when they get oily, the surface gets tightened and the water cannot penetrate anymore. So they cannot attach that well anymore. So in the sequence, it's good to have first the dry mixing,
and then
the water solution, then the oily solution, and then the total mixing down.
Let us broaden the question in how are you adapting to increasing process energy costs? Geke, how should you adapt the increasing process energy costs? I mean, I don't know if there are easy steps to take. Let me state steps to take, to consider.
When it's about the technical stuff, I leave the word to Ernst. But what I am coming across as well is taking from a different perspective. For me, it all starts with maintenance. So making sure that what you produce, that you produce it correctly. Don't jeopardize on your maintenance budget in order to think you are doing fine, but in the end you will regret it. And what also is really very important is that the people working in the operations, that they have a very clear understanding of their role, what they need to do, that they have clear instructions. Because
what do you mean by that they have clear instructions? Because
when you have all these process controls, an operator really must know very well, like, can I push the button on this process control, or should I never touch it? Or so when these alarms are going off, what do I need to do to really make sure that in the process that you are continuously on top of that and that you adapt to that. So I think, and sometimes I say to people, because managers, they make big instructions, they know, they think they know exactly how to do it and tell the operators what to do. And what I sometimes tell to these managers is, just do a day in a life with an operator. Just stand next to this operator for the whole day and watch and see what he is doing the whole day. And then you have a much better understanding of what that operator needs from you to be able to do an excellent job. So that would be my advice for the managers.
Yes.
Do this and you will really learn a lot from the job that the operators are doing, because it's a very heavy job.
Okay. Paul, I mean, what would you say? I mean, if you had to, we have increasing process energy costs. I mean, but what should you do to adapt? Well, there's again, I don't know if it's an easy way. It should.
I
be
think
easy,
you can relate it to what is in your span of control. No?
Okay.
So the fact that you have fixed and variable costs is there tomorrow. It might, go up and go down. But what I see often in feed mills is when the biosecurity is in good shape. You have a clean floor. You basically can eat from the floor.
All right.
It's that clean.
All right.
Then you see as well that the staff is maintaining education of staff. The people make the difference, and really in the operator in front of the palletizer, they are the one. They are the chef cuisine.
So if you're listening right now and you know that there's maybe some work in that field, what's the first thing that you should take?
Yeah, I think it's a good advice for plant managers to focus on biosecurity for several reasons, quality related, but as well to get the momentum in the feed mill that people are aware of their own product. And that is where you can make a difference, and that is where a farmer will distinguish your feed from your neighbor.
And that's what we want. Ernst, I mean, what would you be you have said several things, of course.
I mentioned several things, and my last sentence is maybe one of the most important ones you mentioned already. Maintenance, it's a good maintenance, preventive maintenance instead of breakdown maintenance. It's a good contribution to saving production costs. And the other thing is, in my opinion, also education of the operating staff, of the maintenance staff. It's in many places not good enough.
Okay, it's not good enough. So there's room for improvement.
They know where to start and they know where to stop. The two buttons they know.
Yeah.
The best example is the damper on the 8th floor, if you have paid attention. On the cooler. Who is going up to the 8th floor to close the damper? Because the elevator is broken. Don't forget. You have to walk up on 45 degrees. Oh no, too far.
Too far.
Just leave it.
And that's why it's so good if a manager works with such an operator for the day, because then this manager is thinking like, okay, what can I do differently so that he has an easier job and will do it.
Yeah.
Because it has to happen, yes. And finally, coming in, the one of the remarks is that you could also consider energy contracts negotiations.
Oh, okay.
I don't know if it's very, but I mean, if you succeed.
I'm not sure whether there are many parties who will fix you now for a 3-year period. Now we increased 100%. So.
Well, within Europe, I'm sure that I think they're not there. But since we have attendees from other parts of the world, there might be some local that is feasible. And if you can reduce the energy cost by, I don't know, even 5%, it's a lot. So, I mean, it's a tip. Within Europe, I think that is utopia.
Depends very much where you live.
That it is, yes.
If you live in Middle East, there's enough energy.